This is 1.7, Linear Inequalities and Absolute Value Inequalities. In this part 1, because there'll be a couple parts to this, we're going to look at how we go about solving an inequality. So when we solve an inequality, the process is very similar to solving regular equations, first of all, but there are some tricks to it. So basically, when we talk about an inequality, we're talking about the symbols greater than, less than, greater than or equal to, or less than or equal to. So we're going to be involving variables with these symbols, and we're going to come up with a solution set. So when we do this, we're going to do what's called interval notation. And before we start actually solving the problems, we're going to practice writing things in interval notation. So below, you're going to see a chart, and it says set notation, and we're going to go through each row, and we're going to write that up in interval notation, and then we're going to do a graph. So in set notation, this, and I'm going to highlight what I'm talking about, reads as x such that x is a value in between a and b. In interval notation, if you're dealing with a less than sign or a greater than sign without the equal, you're going to use parentheses. So this looks like this. A is the far left point, and B is the far right point. But those 2 points are not included in my solution. That means x goes up until A but does not hit A, and x goes up into B and does not hit B. So on a graph, if we have A and B, the graph would look like this. We'd have open circles at A and an open circle to B. So all those values in between would be considered x. Okay, let's look at the second one. X such that x is a value that is equal to and in between A and B. So do you guys see that there is a less than or equal to sign this time around? That means that A is included in the solution set, and so is B, and so are those values in between A and B. So I write this up with a square bracket, A, comma, B, square bracket. Square brackets mean that there is an equal to sign with the inequality. So if I would graph that, that means my solution set is from A to B, and the points A and B are also included. All right, let's look at this third scenario. X such that x is in between A and B, but B is included. So we would write this up as parentheses A, because A is not included in the solution set, to B, which is included. So I would use a square bracket with B and an open parentheses with A. So graphically speaking, that looks like this. Open circle with A because it's not included. The values go up into A but do not include it. And closed circle with B because that value is included. In the fourth example, we have x such that x is a value between A and B where A is included and B is not. So this looks like this. Square bracket with A and then parentheses with B. So that looks like this. Closed circle with A going to open circle B. All right. 5. X such that x such that x is greater than A. Now that means that all values are bigger than A but not including A. So if they're bigger than A, then A is the starting point, but it doesn't hit A and it goes up to infinity. Whenever you use infinity or negative infinity, you will use a parentheses. Okay, so A, comma, going up to infinity. So what does that look like on the graph? So A, open circle, going to infinity. Okay? All right, 6. X such that A is greater than or equal to A. Now A is included in the set, So again, x is bigger than or equal to a. So if a is included, I use a square bracket going to infinity. So close circle going to infinity. Number 7, x such as x is less than b. So all values of x are smaller than b. So if b is the biggest value, you have a parentheses here, and it's going to negative infinity. Okay, so if b is the value, open circle, going to negative infinity. So it would look like this. We're going to the left of b. And finally, 8, x such that x is less than or equal to b. So that means that b is included in my solution set and all the x values are smaller than it. So b is included and I'm going to negative infinity. So again, b is included, so close circle with that, going to negative infinity. So those are the different options that we're going to run into. Hopefully you understand that. We're going to move on here. And we're going to look at a linear inequality. So now we're getting ready to solve them. What do linear inequalities look like? If it's a linear equation, when we did those, we know that x is to the first power, right? So linear is y equals, mx plus b, for instance, right? So now we have ax plus b is less than 0. Ax plus b can be greater than 0. Ax plus b can be less than or equal to 0, and ax plus b can be greater than or equal to 0. So these are my four possibilities of what I might run into. So again, we solve these much like equations, but as far as isolating the variable on one side, however, there is one trick to it. If on your very last step, if you're multiplying or dividing your variable by a negative number, you must reverse the direction of your inequality sign. And this only happens when you have a negative number. Okay, I'm going to show you some examples where this happens. Okay, this is going to be the end of part 1. Thanks for watching. Please watch part 2.